Alright, in this video we're going to be talking about the derivative of trigonometric functions. So before we saw, so recall the derivative of, if you're given y equals sine of x, then the derivative of y is equal to cosine of x, and if you're given y equals cosine of x, then the derivative of that is going to be equal to negative sine of x. And I told you that you could show this using the definition of the derivative. You could actually show this. I think we did show one of these as being the case. Now, by knowing the derivative of sine and cosine, we can actually use the quotient rule to find the derivative of the four remainder trig functions, meaning tangent, cotangent, secant, cosecant, and did I say cotangent? Tangent, cotangent, secant, cosecant. Yeah, that's all four. So without further ado, let me just give you what those derivatives are, and I'll show you how you will derive one of them. And then we'll do a couple of examples. This first one you absolutely have to memorize because it will absolutely be coming back. So let me really quickly write this one. This is derivatives of trig functions. So derivative of tangent of x, this one is the one that you definitely have to memorize because it's going to come up throughout the whole class, is secant square x. So if you see somebody in the train and they ask you what is the derivative of sine, you tell them the derivative of sine is cosine. If you see somebody on the bus and they tell you what is the derivative of cosine, you tell them the derivative of cosine is negative sine. And if you somehow walk to school or to work and some person stops you in the street and asks you what is the derivative of tangent, now you could tell them that the derivative of tangent is secant square x. The derivative of cotangent of x is equal to negative cosecant square x. And the derivative of where's my undo? The derivative of secant x is equal to secant x times tangent of x. Finally, the derivative of cosecant of x is going to be equal to minus cosecant of x times cotangent of x. So these are the four remaining derivatives that we needed to know. So we have completed the derivatives of all the main trigonometric functions. We have not yet seen the derivative of their inverses, like sine inverse, cosine inverse, tan inverse, and so on, but we will see them later on in the semester. I'll definitely introduce them to you later in the semester. Now let me just show you the proof of the first one, of tangent of x being equal to secant square x. So first of all, let's consider, well, let me rewrite this. So the claim that we're making is that the derivative with respect to x of tangent of x is equal to secant square x. So that's the claim. So that's what we want to show. So here's the proof. So let's assume, well actually let's consider, because this is not an assumption, let's consider tangent of x. We know that tangent of x is equal to sine of x divided by cosine of x. We know that's a fact. If we apply the quotient rule, we have the following. If we apply the quotient rule, we have the following. The derivative with respect to x of tangent of x is the same thing as, well, it's going to be the same thing as f of x, well, g of x times f prime of x minus f of x times g prime of x divided by g of x squared. That's by the quotient rule. Now, like I said, remember, tangent equals sine over cosine. So instead of working with tangent, I'm going to work with sine over cosine. So remember, tangent of x is equal to sine of x over cosine of x. And if we focus on this, since I'm taking the derivative of tangent, it is the same thing as taking the derivative of sine divided by the derivative of cosine. So we will let f of x be equal to sine of x and g of x be equal to cosine of x. Okay, so now we have the derivative of f of x from before, it's just cosine of x, and the derivative of g of x, again from before, is negative sine of x. And now we could put this back together. So d dx tangent of x is equal to g of x, which is cosine of x, times f prime of x, which is also cosine of x, minus sine of x, right, times the derivative of the bottom, which is negative sine of x. And I'm adding an extra parenthesis because there's a negative sign, divided by the bottom square, but the bottom is cosine of x, so divided by cosine of x squared. Well, cosine of x times cosine of x is just cosine square x. And then minus, well, sine of x times sine of x is minus sine square x divided by cosine of x squared. Well, minus times minus is plus, so in the top I have cosine square x plus sine square x divided by cosine square x. I simply move the exponent to the inside. But note that and we covered this in the review for pre-calc, you should know this, cosine square x plus sine square x is the Pythagorean identity, and we know that's equal to 1. So this sum, cosine square x plus sine square x, we know that's equal to 1. So what we have here is, instead of cosine square x, so I'm going to continue here, so instead of cosine square x plus sine square x over cosine square x, I could write now 1 over cosine square x, because of this fact. I could substitute it and make it a 1. But now, notice that I have 2 cosine squares in the bottom, so this is the same thing as having 1 over cosine of x times 1 over cosine of x. I could just split it because I have 2 of them. Remember that when we have a fraction, we multiply across, so I didn't change anything. 1 times 1 is 1, cosine of x times cosine of x is cosine of x squared. So I haven't changed anything. But the reason why I'm doing this is because 1 over cosine of x is exactly secant. So if you don't remember from trigonometry, from pre-calc, 1 over cosine is the same thing as secant of x. That's how we define secant. This is a reciprocal of cosine. So here what I have is 2 secants of x. Secant of x times secant of x. But that is precisely secant square x, because I have 2 of them and I'm multiplying them. So remember what I was trying to solve was the derivative of tangent of x. So we have the derivative of tangent of x is equal to secant square x, much like we claim it was up here. So that's how you show that this is in fact true. You could follow a similar argument with the other 3, and I'll leave those as an exercise. So if you want more practice on taking derivatives, practice with these 3 other ones. So all you have to do is apply the quotient rule and be a little bit clever about it. Okay, so let's do an example of taking derivatives of trigonometric functions. So example number 1, let's say you're given the function y equals x minus tangent of x. Well, somebody told you to find the derivative, so find y prime. Then y prime here is simply going to be the derivative of x, which is just 1, minus, well, what is the derivative of tangent of x? We just calculated that. That's just secant square x. Okay, so that would be the solution for this. Y prime is just 1 minus secant square x. How about this one? What if you have y equals x secant of x? Well, this is much more complicated than the first one because here we have a product. We have two functions being multiplied by one another. So that means that we have to use the product rule. Here we have the case where we have f times g. And remember, f times g was the first times the derivative of the second plus the second times the derivative of the first. For the product rule, it doesn't matter the order, but I suggest you keep it in this order because this order will help you remember the quotient rule. In any case, let's figure out what f of x and g of x are. Here I'll say f of x is x and g of x is secant of x. So that means that f prime of x is simply 1. The derivative of x is just 1. And g prime of x, well, that's secant x, so we actually have that rule now because I wrote it for you. It's right up here. So the derivative of secant of x is secant x times tangent x. Okay, so that's just secant x times tangent of x. This is secant x times tangent of x. Okay. So what do we have here? So we have that y prime now is going to be equal to f of x times g prime of x plus g of x times f prime of x. Well, we know what f of x is. F of x is just x times g prime of x, which is secant x times tangent x, plus g of x, which is just secant x, times f prime of x, which is just 1. Well, this simplifies to you can multiply the x through, so you get x secant x times tangent x plus secant x. Notice that both of these terms have secant of x, so we could factor the secant of x out. So this is secant x times, and what we're left with in the first term is just x and tangent of x. This is x times tangent x and then plus 1 because we factor out the secant out. We factor out secant. So if you multiply it out, you'll see that you get the same thing. So that's the solution for this. So if you use the product rule here, we have that the derivative of x secant of x is secant of x times tangent x plus 1. Notice that the derivatives are getting more complicated. That will be the case for the rest of the course. The derivatives that we will explore are going to be more convoluted, and it will use all of these rules at once. All of these rules that we were learning, they will be used at once. So here we had a case of the product rule, which we covered in the first part of this lecture. Let's do another example. So a little bit more of a challenging one. And this is because we have multiple forms. We may have multiple forms of expressing a derivative. So we want to differentiate both forms of y equals 1 minus cosine of x over sine of x, which is actually equal to cosecant x minus cotangent x. So if you were to simplify this, you get this. That's basically what this is saying. And what I'm going to do is I'm going to first take the derivative of this part and then just the derivative of that part, and then show that the derivatives are actually equal. So let's do the first part, which is just the fraction 1 minus cosine of x over sine of x. Well, notice that we have to use the quotient rule here because we have a fraction. So the quotient rule says the derivative is going to be g of x times f prime of x minus f of x times g prime of x divided by g of x squared. I'm going to keep on writing the quotient rule every time that we do a problem so that, you're reminded of it. So you can memorize it. Well, let's find out where f and g should be. I'm going to say f of x is the numerator, so that's 1 minus cosine of x. And then g of x is going to be the denominator, which is just sine of x. Well, f prime of x is going to be equal to what? The derivative of 1 is 0, and the derivative of cosine is negative sine, so this is minus sine of x. Always be careful when you have a negative sign. And then the derivative of g of x is going to be cosine of x. So the derivative sign is cosine of x. So we have f prime of x is equal to sine of x. Okay, so now what? Well, now we put it together. So y prime is g of x times f prime of x. So that's going to be equal to sine of x, that's our g, times f prime of x, which is also sine of x, minus f of x, which is 1 minus cosine of x, times g prime of x, which is just cosine of x, divided by the bottom squared. Well, the denominator is just sine, so this is going to be sine x squared. So that means that y prime is equal to sine square x, because we have two of them being multiplied. And then cosine times 1 is cosine, that's cosine of x, minus cosine times cosine is cosine squared, so minus cosine square x, divided by sine x squared. Okay? And now we could distribute that negative sign. So we have sine square x, and then minus cosine of x, plus cosine square x, divided by sine square x. But remember, we could rearrange the numerator now. So if we rearranged it, we could write this as sine square x plus cosine square x minus cosine of x over sine square x. And it turns out that once again, we have sine square x plus cosine square x, that's just going to be 1. So we have 1 minus cosine of x in the top. The sine square x plus cosine square x became 1, divided by sine square x. So that's the derivative of the first piece of this fraction. You notice they're almost identical, it's just that the denominator now is squared. But now we also have the other form, so we also have cosecant x times cotangent x. So let's do the other form, so let's call it 2. So y now is equal to cosecant x minus cotangent x. And from before, I'll just rewrite this derivatives. Cosecant x, its derivative is equal to negative cosecant x times cotangent x, and the derivative of cotangent x is equal to minus cosecant square x. Okay, so writing this down because it's going to be useful. So y prime is literally what I wrote here. Cosecant x is just minus cosecant x times cotangent x, and minus cotangent x is simply going to be, well, minus times minus cosecant square x. So that means that this derivative is equal to minus cosecant x tangent x plus cosecant square x. Okay. Now, how do we actually verify that these two derivatives are equal? Because I said that they were going to be equal up here. I said that these two forms are going to give us the same derivative, and they should, because these two things are equal to one another. We have two equalities here. And so far it doesn't look like they are, because here I have 1 minus cosine of x over sine square x. So from the first one, we have that y prime is equal to 1 minus cosine of x divided by sine square x. Well, if we write it as 1 over sine square x, meaning if we break up this fraction, and then minus cosine of x over sine square x, then we'll be able to actually see it. So let's see. We could actually break it up a little bit more, because it's 1 over sine square x, and then I could say minus 1 over sine of x. No, the bottom is being squared, so I could write it like this, times cosine of x over sine of x. This is perfectly fine. I'm just multiplying across, so I'm going to get back the same thing. But now notice, 1 over sine square x is the same thing as cosecant square x, because cosecant is defined as 1 over sine. So recall, I'll do it down here, recall cosecant of x is equal to 1 over sine of x. And just for the sake of argument, also recall that cotangent of x is equal to cosine of x over sine of x. This is from your trigonometry class. So here I have this fraction, the first fraction right here becomes cosecant square x, then minus 1 over sine, we know what that is, because I just wrote it here. That's also cosecant of x, but I'm multiplying this by cosine over sine, but that's just cotangent of x. So this first derivative that we found is exactly equal to the derivative that I have up here. It's just rearranged. Notice that I have minus cosecant x cotangent x, minus cosecant x cotangent x, plus cosecant square x, and this is a plus cosecant square x. So they actually are identical. I mentioned before that I was going to give you a way of remembering the quotient rule. So let me rewrite the quotient rule once more. This is the way that I remember it. Okay, so if we have the quotient, we're taking the derivative of the quotient f of x over g of x. I remember it like this. We know that that is g of x times f prime of x minus f of x times g prime of x divided by g of x squared. So the way that I remember this is literally by saying in my head, low the high minus high the low bottom squared. So I literally say that in my head. Low the high minus high the low bottom square. So low times the derivative of the top minus top times the derivative of the bottom square. So low refers to the g of x, the high derivative of the top, meaning the derivative of the high one, minus high times the derivative of low. So that's how I remember it. Low the high minus high the low bottom square. And I literally repeated that over and over again until I remember the formula. This is a formula you cannot forget, especially the order, because the order matters. For the other one, you could just say first times the derivative of the second plus second times the derivative of the first for the product rule. In any case, I hope this is useful. I hope this is useful to you when trying to memorize the quotient rule. Thank you for your time.